The topic is classifying zeros of polynomials. So let's do these examples. The graph and degree of a polynomial with real coefficients f of x are given. So we know the degrees of all these graphs, 6 graphs. Let's call this graph A, B, C, graph D, and then this is graph E and graph F. Alright, so we're assuming that all the zeros of f of x are distinct. In other words, all of them multiplicity 1. And we need to determine the number of real zeros and the number of imaginary zeros. So first, what we need to know, the number of real zeros are just the x-intercepts, if there are any. And whatever it's left has to be the number of imaginary zeros. Now, remember also, we know from the conjugate zero theorem that if a polynomial has only real coefficients, and if a plus bi is a zero of f of x, in other words, imaginary zero, then the conjugate a minus bi is also a zero. In other words, the imaginary zeros, they exist in pairs. Alright, so let's do example A. For example A, it's given that the degree is 2. See, the degree is 2. Since we have 2 x-intercepts, so it's fine. So we have 2 real zeros. So the answer will be 2 real zeros. Right? And the degree is 2, so it's fine. Second problem, B, the degree is 2. It's given. Now, we know that there is no x-intercept, means there is no 0 real zeros, but because the degree is 2, we will have 2 imaginary zeros. And it makes sense because we know that imaginary zeros exist in pairs. So 2 imaginary zeros will be the solution, or the answer for question B. For question C, the degree is 3. So we know there is one real solution because there is one x-intercept. So we know there is one real zero. So therefore there are going to be 2 left because the degree is 3. But the 2 that are left are imaginary zeros. 2 imaginary zeros. Now for D, we have 3 x-intercept, which means 3 real zeros. So, since we have 3 real zeros and the degree is 3, there is nothing left for imaginary zeros. So, that's all. 3 real zeros, no imaginary zeros. For the degree 4, for E, we have no x-intercept, which means 0 real zeros. We have no real zeros, and therefore, since it's a degree 4, then we're going to have 4 imaginary zeros. 4 imaginary zeros. But of course, don't forget, we are assuming that the zeros are distinct. See, the zeros are distinct. It's really important, otherwise we can't do this. Now, the degree is 4 for F. Degree is 4. We have 2 real zeros, see, 2 x-intercepts. So therefore, we have 2 real zeros. And because the degree is 4, there's 2 left, so we will have 2 imaginary zeros. 2 imaginary zeros. Pretty easy. So that's it for this example.